Hi, I'm very excited to be here at the ReactiveConf stage. My name is Meltem, and today I'm here to talk to you about how a 16th century mathematician helped me and other awesome folks back in Toronto to build a design system for a large e-commerce platform. So a little bit about me. I live and work in Toronto, Canada, at a front-end consultancy called Wrangle.io. And it's funny, if you go to the website, like wrangle.io, I'm on the main page, and it's like so random, but I was like, it kind of works out for my about slide. And I'm originally from Ankara, Turkey. Even though that picture is from Istanbul, I couldn't find a picture of me as an adult in Ankara, so I just put it there. Yeah, I'm from Turkey originally, and you can find me on Twitter at trilingualmel. Yeah, so so my talk is kind of like in two sections. In the first part, I'd like to briefly touch on design systems, and then in the second part, I will talk about how this 16th century French mathematician helped me and some other people build a design system. And first of all, I'd like to get a lay of the land. Anyone heard of design systems before? Okay, actually not a lot of people, so that's good. So it's not going to be like everyone already knows this, that like I'm just like repeating what everyone knows. Cool, yeah, then the second part will make more sense once we kind of like cover what a design system is. So in a nutshell, design system is a systematic approach to product development. So it includes tools, guidelines, shared principles, and code that enables teams to work more efficiently and build consistent products in collaboration rather than in silos. And we can call it as a single source of truth for all of the product teams under a brand. So what you might be wondering, like, why we need a design system, is this a problem? So for brands like Google or GitHub or like Airbnb that have different products and they have different product teams, actually, a lot of the things that these product teams design or develop ends up being similar pieces. For example, the spacing scale, the typography scale, or the JavaScript components, the front-end components that they're using. When there are lots of product teams, it's just better to have a dedicated team that is responsible to think about, build, and design all these reusable pieces so that product teams can actually focus on the challenges that are specific to those products. So in that kind of a scale of a brand, design system actually helps these teams to build more consistent products and be more in sync, other than them kind of like maybe copying and pasting some CSS from one code base to another. So talking about Google, I put some examples of like existing design systems available out there. Material design is by Google, and I guess like a lot of front-end developers know this. Like I once built like a side project using it. So there's GitHub, which has Primer. Shopify has Polaris. Carbon by IBM, and also there are other design systems by other players. And they have, if you kind of like do a quick Google search, they have like really good like blog posts where they talk about their journey, about like building, scaling, maintaining a design system, and also how you can see how kind of different their design systems are just based on like their needs of like their products and their brand. So design system has different parts to it. So this one is more the design system project I worked on. We have this kind of structure, so I'm gonna kind of cover this one, but it might like change slightly, but at the same time, pretty much similar, I find. So it has design language, design kit, component library, developer sandbox, and documentation. So design language is basically visual, the visual design of a digital product. So it defines characteristics like typography, colors, spacing, all those design guidelines that designers basically use to design different products. And it is represented as design tokens in the code. It is also maintained as design tokens in the code because in a design system, you always want to keep the design and the code in sync. The design kit is where the symbols or components for designers to use live, and they can build experiences or prototype experiences using these available symbols in the design kit. And design kit always needs to be kept in sync with component library, and there's some sort of a mapping in between, even though not maybe one-to-one, but it's kind of like you have your button component in the component library and you have your button symbol in the design tool that you use. Component libraries where you have your JavaScript components, they're version controlled, and they're basically the building blocks of your applications. Different product teams can use these components to build bigger applications and products. And developer sandbox is where where the components live and where you visualize, test your components without having to run an entire application. So you basically have your components in isolation. And last but not least, documentation side is where the end user of the design system goes. So all your components, like component code, all the dev and design considerations you you come up with when building the design system lives there. Also, all the design language, like the guidelines and rules, they all live in the documentation site. Yeah, so this was like a quick overview to design systems, and the second part of my talk is about how to deal with component variation rendering when, as a design system developer, developing all these different components, and how actually this mathematician helped automating that. So yeah, when you're a developer in a design system project, this can be also a component library actually. It doesn't have to be necessarily a design system. So you have like different components. You have like buttons, inputs, checkboxes, like labels, like all these components that you need to build. And then you have different variations for these components. So here I picked a button component from the design system that I worked in. And as you can see, we have like 12 different instances of this button combined with like variations of different properties. So we have like a theme to this button. There are like 3 themes, and then it can take in an icon optionally, and then it can be like a slightly small button. And this is just like kind of 3 properties, and then they take in different values. So if I were to like if I were to like render these components, normally what I would do, let's say I'm using React as my front-end framework, I would basically just write this component, an instance of the component, defining its props, and these props take in different values, and I would come up with like combinations of it so that I can have I can see all these like variations rendered. So we have the variant prop corresponds to this theme of the button. So we have primary, secondary, and transactional. And then, as I mentioned earlier, it can take in an icon optionally, or it can not take an icon, and it can be a small button, or it can be a small button with an icon. And this is valid for all the 3 different teams of the button. So as you can see, I have just like 3 props, and then one of them takes in like 3 values, the 2 other takes in 2 values, and I already have a lot of code. I need to like write the instance of the component once for all of these combinations, and I kind of need to think about, oh, okay, like, did I include all the use cases, all the like combinations that can happen? And like, as developers, we usually like don't like to write lots of code like this. We want to, wherever we can, like we want to actually automate things and just make things easier. So here, actually, René Descartes helps us with his the concept that he developed back in the 16th century called Cartesian product. So in a nutshell, given 2 sets with elements, Cartesian component will include every possible combination of the elements in these 2 sets. So here we have set A, we have cat and a dog, and then in the set B we have chicken and milk. And when we make the Cartesian product or cross product, then we have all the possible combinations between these elements, which are a dog and a kitchen, a cat and a milk, a dog and a milk, and a cat and a chicken. So we can actually leverage this for our component and its prop values. So let's say for the button component, I have the variant prop and I have the icon prop. Variant prop can take in 3 values, and icon can take in 2 values. And then when I make the Cartesian product of these two props, I get 6 different combinations of them. And using this, I can actually create a component that can render a given component with the combination of its different prop values. So for button component, it looks like this. I have my Cartesian component, and then I pass in the button, I pass in children, if there's any, and then I pass in the prop values in an array. And also I have a container prop here that Cartesian component takes in, and it's this one is used to display a list of the values that correspond to the prop for every instance, which you're going to see here. So this is basically, I'm doing the same thing as compared to what I showed earlier. I have just that list. It is just for convenience. It's there, so I can see like every instance which prop value it takes in. But as you can see, this is like way cleaner than writing the every instance of the component manually. And also, let's say like I want to change a name of a prop or a value, I can just go and change it over here once, and then it's going to get reflected. Versus in the other case, I had to do that for every instance, which is really error prone. Also, what if I want to add a new prop? So I want to actually display this component, given that there's another prop and it's got some other values. So I just add that to the Cartesian component, and I define the values that this prop needs to take in an array. And then Cartesian component is going to render the component in combination, this prop of this component in combination with other props. And I can see how it looks. And this is really, like when you're building a component library, this is really important because, yeah, you want to make sure that all these combinations, your component looks right in all these combinations. And this is the component API. So what I've showed was how to use the Cartesian component. And here we can see the component API. So we have a container, a component, and we destructure the rest of the props. And then here, this is how we get the combinations of the prop combinations using Cartesian product function that takes in the props. And I'm not going to go detail into this part, but if you're curious, I've included a link at the end. Yeah, so there's kind of a piece of logic here to make these combinations available to the Cartesian component so it can render the component with these combinations. So here we map over these combinations, and then we render, if there's a container, we render that. If there's children, we render that, and then we render an instance of the component for every possible combination of these prop values. Other than component variation rendering, where Cartesian component was useful for us in testing as part of building this design system. So we've used it in a similar manner in terms of getting our snapshot tests done, and it helped us just the burden of like writing these tests like one by one. We could just leverage Cartesian component to get our snapshot tests for our components. And we also use it for accessibility testing. So accessibility was an important part of our design system, our components. And again, Cartesian component was useful for us when we were writing our accessibility tests for our components. Yeah, so as a user of the Cartesian component in this project, I really liked it because even though like writing every component, for example, meant that we had to write a Cartesian component for it, but it just made our life as developers way easier. It improved our workflow, gave us the chance to get an instant feedback when building these components to see if anything was broken or not, if everything looked good. And it's also pretty lightweight, so it's just a React component or a component that you can write in other frameworks as well. So it doesn't require any extra setup, installing any NPM packages or anything like that. And yeah, it just helped seeing all these, when you have all these like components with different variations, to see when you're developing that, if you get the styling right, if you get the responsibility right and everything. So I find it really cool, and I'm hoping that this kind of like because it combines this Cartesian product concept with componentization concept. And if you're tackling with a similar problem, maybe in a design system or a component library, or maybe another problem that might make use of this kind of an approach, I'm hoping that maybe this is something you're going to remember when you walk out of here. So I've included some links here. So the first one is a blog post about what a design system is by a couple of my colleagues at Wrangle that I worked with together in this project. And then the second one is the Cartesian component API is available there. The third one is, again, one of my colleagues at Wrangle. When I shared this with him, he really liked the idea, so he just came up with the Vue version of it. And if you want to see it, this Cartesian component in a different framework, you can check that out. And also the last one is the implementation of getting the Cartesian product of component props. And that's all I've got for you. Here is the link to the slide deck, and you can again find me on Twitter at @trianglemel. And thanks for coming and listening.